So the given question, example 3, PQ is a card of, so they have given PQ is a card of length 8 cm. This is a card of length 8 cm. And the circle of radius 5 cm. So that OP length is 5 cm. Radius is 5 cm and the length of the card is 5 cm and 8 cm now. Now the tangents P and Q intersect at the point, tangents at the point P and Q, they intersect at the point T. So these are the two tangents drawn from the external point T. TP and TQ, they are the tangents. We need to find out the length of this tangent now. For this we need to do some construction. You can join the centers here from center to this external point. So if you join like this, so you will get a triangle. Look at this in triangle TPQ. So let us write the construction here. Solution. Join OT. So you are joined OT now. Now you consider triangle TPQ. In triangle TPQ, all of you look at this. Triangle TPQ. These are the two lines drawn from the tangents drawn from the external point. They must be equal by theorem 10.2. TP is equal to TQ. You can write TP is equal to TQ by theorem 10.2. So tangents drawn from an external point, they are equal. Therefore TPQ is isosceles. Triangle TPQ is isosceles. And another thing, you have studied that in the theorem. So this line joining the center and the external point will bisect this angle, because we proved that these two triangles are congruent in the previous theorem. So we proved that this OT will bisect, also OT bisects angle PTQ. So this is also by the theorem only, theorem 10.2. As you have studied that in the theorem, suppose if there are two tangents drawn from the external point, then the line segment joining the center to that external point will bisect the angle. Because you can prove that these two triangles are congruent. You can prove that these two triangles are congruent, then only we prove that these tangents are equal. At the same time, these two angles equal, and I told you these two angles also will be equal. That means this will be the bisector of this angle. So that we learned in the theorem. The same thing we are using here. So these two angles are equal. That means OT is the bisector. OT is the bisector angle PTQ. See, in an isosceles triangle, bisector of an angle, vertex angle, will divide the base into two equal parts. As you have studied in the lower classes, suppose this is an isosceles triangle. So ABC is an isosceles triangle. If I draw the bisector of this angle, if these two sides are equal, bisector of this angle will always bisect the base perpendicularly. This angle will be 90 degree and this will be bisected into two equal parts. So therefore, you can write the same thing here. So OT must be, so therefore OT is the perpendicular bisector. OT is the perpendicular bisector of chord PQ. Of PQ. So that means, so let it intersect. So let us take some point M. Okay. So R, otherwise we can take R. So let us take this point as R. So this OT is intersecting PQ at R. So this OT is perpendicular bisector. Therefore, I can write PR is equal to RQ. PR is equal to RQ. Total 8 cm means PR and RQ are equal, means both will be equal to 4 cm. Now this is 4 cm and this also 4, because total length is given 8 cm and this angle is 90 degree and this is also 90 degree. So these two triangles are right angle triangles. So you can write angle PRO is equal to angle PRT. So both are equal to 90 degree. So we proved that these two angles are equal. Okay. So now after this, now you select the triangles now. In triangle, see these two triangles are similar. These two triangles are similar. Now before that, this is a right angle triangle. Is it not possible to find out the length OR? How can you find out the length OR? You can use the Pythagoras theorem in PRO, in triangle PRO. PO is our hypotenuse. I want OR square. So OR square is equal to OP square minus PR square. OP square minus PR square. So this gives you OP square minus PR square. OP square here 5 square minus 4 square. So that is 25 minus 16. So it is 9. So OR square is equal to 9 means OR will be equal to 3 centimeter. So you got this length as 3 centimeter. So this is 3 centimeter now. Okay. So you got this length. PQ is 8. PR is equal to 4. And this is 3 and this is 5. So now after this, you know that angle TPR plus OPR both are equal to 90 degree. TPR plus OPR, because this is a radius and this is a tangent. So radius and tangent are perpendicular. So I can write angle TPR plus angle OPR both are equal to 90 degree. Okay, because theorem 10.1, radius and tangent are perpendicular. And at the same time, I can also write, see, two angles, these two angles also 90 degree. So this angle and this angle. Because this is a right angle triangle, this itself is 90 degree. As this angle itself is 90 degree, then the sum of the two angles must be 90 degree. I will write angle TPR this one, and angle PTR. TPR plus PTR is also equal to 90 degree. So you can write angle TPR plus PTR both are equal to 90 degree. So this is angles of property. So you can write angles of property. Because the third angle is 90 degree, one right angle, the remaining angle must be 90 degree. Now you compare this one. So from these two, here TPR also same, here 90 degree is same. Therefore I can write angle OPR must be equal to angle PTR. So this is the conclusion you are getting. Angle OPR is equal to angle PTR. What is that OPR? Angle OPR means this angle. So I will write, so this angle OPR is equal to PTR. We proved that these two angles are equal. Okay. Now in these two triangles, look at the triangles. Triangle PTR and OPR. Can't you prove that these two triangles are similar? You have proved that this angle is equal to this angle and these two angles are 90 degree. So therefore I can write PTR and OPR, they are similar to each other. So we will write which are the angles similar. Look at this. So in this triangle, angle T in PTR, suppose in PTR and OPR, which are the angles which are equal? So angle T is equal to angle P. Here angle T, here there P. Here angle R only. So then what is left out here in TPR? So here we have taken T, R and then P is left out. So then here P, R, then O is left out. You can write TRP is similar to PRO. So I directly write. So therefore triangle TRP is similar to triangle PRO. Look at this. TRP similar to PRO. We have explained because these two angles are equal and these two angles are equal and these two angles are 90 degree to each other. So therefore you can write the triangles are similar. If the triangles are similar, then the corresponding sides are proportional. TR by PR, RP by RO, then TP by OP. First two, TR by PR, RP by RO, then TP by PO. So now you take only the ratio TP by PO and RP by RO. These two you take. So in this you substitute the values that you know. So TP let us keep as it is. What is the length of RP? What is the length of RP? Look at the diagram. RP 4 centimeter. So you can write here 4 centimeter divided by RO. Look at the diagram. RO, it is 3 centimeter. So you can write there 3 centimeter. So is equal to TP, we need to calculate, that is the tangent length. Then OP, look at the diagram. What is OP? OP, it is a radius. So you can 5 centimeter. You can use there 5 centimeter. So this is 5 centimeter. So from this ratio you can calculate the TP. So therefore TP is equal to, cross multiply, 5 into 4 divided by 3. TP is equal to 20 by 3 centimeter. So this is the length of the tangent. Again. So here PQ is a chord they have given and it is 8 centimeter in length and the radius is 5 centimeter. The tangents at P and Q intersect at the point T. These are the two tangents drawn from external point. So you have to find out the length of the tangent. They have given this length, chord length and the radius. Now you know that if you join OT, so you know that by the theorem 10.2, so this OT, what happens will be the bisector of this angle. As I explained in that theorem, so this will be the bisector of this angle. And this triangle is an isosceles triangle because TP and TQ are equal. These two line segments are equal. Only you see this diagram, this triangle. These two sides are equal by 10.2 theorem. Tangents drawn from external point are equal. And this is the two angles which are equal. Therefore, OT must be the bisector of this angle T. If OT is the perpendicular bisector of this angle, so OT is the bisector of this angle means it will divide the base into two equal parts. So this PR and RQ will be equal. As I said in an isosceles triangle, suppose if this is an isosceles triangle, if the bisector of this vertex, bisector of this angle is always perpendicular to the base and bisects the base, that you studied in the congruence chapter, triangles. In an isosceles triangle, the bisector of an angle, the vertical angle, this angle, will always bisect the base perpendicularly. The same property we use here. This triangle, this is the bisector of this angle. This must divide the base into two equal parts as well as that must be perpendicular. So we have proved that this is 90 degree and this is 4, this is 4. Use the Pythagoras theorem 4, 5. You can calculate OR by Pythagoras theorem in this triangle. So you can calculate this side OR. So because OP square is equal to PR square plus RO square. 5 square minus 4 square, it becomes 3 square. Okay. So you got this length 3. And at the same time, you can show that these two triangles are similar. So I will mention, say now this triangle. This triangle, okay, is similar to this triangle. How? We have proved that, see, this sum of these two angles is 90 degree. This angle, because radius and tangent, and come to this one. These two angles also 90 degree because this is 90 degree means angle sum property. This one and this one 90 degree. See, if I write this is 1, 2, 3. Okay, what you can write? 2 plus 3 is 90 degree. Angle 2 plus angle 3 is 90 degree because radius and tangent. Angle 1 plus 2 also 90 degree. Angle 1 plus 2 also 90 degree. Okay. Now 2 and 2 cancels, 90, 90 cancels. What is left out? 1 is equal to 3. So you got this angle is equal to 3. So this angle is equal to 3 and this is equal 90 degree means these two triangles, this triangle and this triangle, they are similar. That's what I wrote here. TRP similar to PRO. Once you write they are similar, you apply that corresponding sides are proportional. If they are similar, apply the sides are proportional. So you can write all the three sides and take the ratio which you know that. I wanted to calculate the length of TP. So this ratio is required. It is must. Then which ratio? Another ratio. Here we do not know TR and PR. So you know that RP and RO. So substitute in this one. RP is equal to 4, RO is equal to 3. So therefore, and OP is equal to 5. If you substitute, you will get the length of the TP. The basic concept here, what we are using. So this line joining the center to the external point will bisect this chord into two equal parts. And you are showing these two triangles are similar. After showing the sides are similar and you are applying the proportionality, sides are proportional, so then by using that proportionality